So we are now on our third gas law, which is the Avogadro's law. Okay, so Avogadro's law, no, is of course determined or proposed by Amedeo Avogadro. So let's talk about the Avogadro's number. So Avogadro's number, no, or constant, no, is defined as exactly 6.022 times 10 to the power of 23. But take note, it was not determined daw by Avogadro himself, but rather si Jean Perrin, no, in 1909. So, si Perrin, he estimated the number by observing the movement of particles in a gas or liquid, specifically through Brownian motion. So, ito si Perrin, no? So, he is Perrin, French physicist siya. He conducted an experiment in the early 20th century, not to study the motion of particles in a colloid, or a suspension of tiny particles in a liquid. So by observing the particles' movement in their settling due to gravity. So he was able to calculate the number of particles in a known volume of the colloid, which led to determination of the Avogadro's number. He provided the definitive experimental proof of the existence of atoms and molecules by, of course, confirming Albert Einstein's theoretical predictions. So by observing the erratic movement of microscopic particles suspended in a fluid, si Perrin, gicalculate niya ang Avogadro's number. Okay? So, ang contribution naman ni Avogadro, so he worked in the early 1800s, and of course that led to the foundational concept of the mole and Avogadro's number. He proposed that equal volume of gases at the same temperature and pressure contain the same number of molecules regardless of gas composition. So, as what you notice, 1800s pa lang, meron ng idea, no, si Amedeo Avogadro. That's the reason why sa kanya pinangalan, no, hindi kay Perrin, no. So Perrin's number sana yung tawag natin ngayon. So more than 200 years ago, no 1800s nga, a paper proposing the idea that equal volumes of different gases at the same temperature and pressure contains an equal number of molecules. So gipublish, no, ito in the journal de Physique. So, ang author ng paper, no, is si Amedeo Avogadro. And his idea became known as Avogadro's law, which is now fundamental concept of physical sciences. So, ano nga ba ang Avogadro's law? So, two gases that occupy equal volumes, okay? So, meaning, what? Constant yung ating volume this time, under the same temperature and pressure, contain the same number of moles or the same number of molecules. At standard temperature, 0 degrees Celsius or 273 Kelvin, and pressure 1 atmosphere or 101.3 kilopascals, 1 mole of any ideal gas will occupy 22.413 liters and contain 6.02 times 10 to the power of 23 molecules. Again, at constant temperature and pressure, equal volumes of all gases contain an equal number of molecules. So, ang constant naman natin, no, hindi ang volume but the temperature and pressure. Okay? So, given the relationship between volume and amount, when pressure and temperature are held constant, remember amount is measured in moles. Okay? So also, since volume is one of the variables, that means the container holding the gas is flexible in some way and can expand or contract just like a balloon. Okay? If the amount of gas in a container is increased, okay, amount of gas, so meaning more volume, of course, the volume increases. If the amount of gas in a container decreases, the volume decreases. Again, putting some gas in a balloon, no? So, ganun yung ano niya. Why? Suppose the amount is increased, this means there are more gaseous molecules and this will increase the number of impacts on the container walls. That's the reason why lumalaki siya. This means the gas pressure inside the container will increase, become greater than the pressure on the outside of the walls. This causes the walls to move outward. So, since there is more wall space, the impacts will lessen and the pressure will turn to its original value. So, ito yung mathematical form ng Avogadro's law. V1 divided by N1, na that represents mole, is equal to V2 divided by N2. This means that the volume amount fraction will always generate a constant if the pressure and temperature remain constant. Okay? Okay, let's proceed with our sample problem number 1. Okay, so 5 liters of a gas is known to contain 0.965 moles. If the amount of gas is increased to 1.8 moles, what new volume will result? No? Of course, at an unchanging temperature and pressure. So, ang formula, no, natin sa ating Avogadro's law is this one, no? So, V1 divided by N1 is equal to V2 divided by N2. So, of course, based sa ginawa din natin sa Boyle's and Charles' law, we have to rearrange this formula in order for us to emphasize what we are looking for. So, in here, napapansin niyo, ang ginawa lang naman, no, is, di ba, kagaya sa Charles law, no, yung nasa baba, no, ng formula is ilalagay lang natin sa numerator sa kabilang side. So, as what you can see, V1, so meron siya sa kabila katabi na N2 kasi i-transfer lang natin. And nag-remain lang yung N1 sa baba. Okay? So, i-distribute natin yung given natin, although hindi ko na siya i-emphasize yung given dito, pero you can put the given para guided kayo. So, we have our V1 here, no, as what you can see, liters, no, basta may liters, ml, no, so that is volume. And ang ating N1, no, this is our N1, 0.965 moles, and we have another given N2, no, which is 1.80 moles. So, ilalagay lang natin yan sa ating formula. V1, 5 liters times 0.96, N2. N2, no? So, 1.80 moles. Ang N1 naman natin is 0.965 moles. Okay? So, i-ano lang natin yan, i-multiply and divide. 5 liters times 1.80. So, of course, makancel ito siya, divided by 0.965 moles. And if you use your calculator, you're gonna get 9.33 liters. Okay? Ganun lang kadali ang Avogadro's law. Another example, a flexible container at an initial volume. So, meron siyang initial volume. Take note kayo sa mga terms na ganito, ha. Of 5.120 liters contain 8.5 mole of gas. More gas is then added to the container until it reaches a final volume of 18.10 liters. Assuming the pressure and temperature of the gas remain constant, calculate the number of moles of gas added to the container. So, first, i-determine muna natin yung given, no? So, we have our V1 here, no, volume 1 natin, 5.120 liters. Ang ating ano tawag nito? N1, no? 8.5. At meron tayong V2. So, ang hinahanap natin, no, is the number of moles, which is our N2. So, ito yung formula natin, di ba? V1 divided by N1 is equal to V2 divided by N2. So, of course, since nasa denominator yung ating hinahanap, no, ilagay lang natin sa taas muna ito sila, no? Ang V1, magkatabi na sila ni N2. Ang V2 naman, magkatabi na sila ni N1. And ito na yung nangyari. So, in order for us to determine, no, our formula, so what based sa ginawa natin sa Boyle's Law, no, pag ganito yung itsura ng formula, yung kung ano yung kasama niya, ilalagay lang natin sa kabilang side, and if numerator siya, magiging denominator siya. This is the reason why yung ating V1 nasa baba na siya dito ng formula. So, ito na yung ating formula. Okay, so yung N2 is equal to V2. Ang V2 natin is 18.10 liters. Ang N1 naman natin is 8.5 moles of gas. Ang V1 naman natin is 5.120 liters. Ilalagay lang natin. Yan. So, 18.10 times, liters ito ha, liters, times 8.5 moles divided by 1.120 liters. So, of course, yung sign dito, no, is maka-cancel. So, if, yon. So, we'll get our answer, right, na 30.05 moles. Okay, but take note, meron tayong tinatawag na initial volume, no, contains 8.5 moles of gas, and we have to calculate daw the number of moles of gas added to the container. So, since meron na tayong initial na 8.5, pwede natin itong i-minus lang sa ating final answer, just like this one. Okay? Kasi, again, ang question is, calculate the number of moles of gas added to the container. Okay? So, diba, i-multiply natin 18.10 times 8.5 divided by 5.12 liters. So, ang result natin is 30.05 moles. Now, ang question is, go back to the question, recheck the question, calculate the number of moles of gas added to the container. So, meron na tayong 8.5 na gas initially. So, in order for us to determine kung ilan yung i-add, we have to deduct, no, that 8.5 moles of gas. And our final answer is 21.55 moles. Sample problem number 3. So, a flexible container at an initial volume, so ito na naman, of 6.13 liters contains 7.51 moles of gas. More gas is then added to the container until it reaches a final volume of 13.5 liters. Assuming the pressure and temperature of the gas remain constant, calculate the number of moles of gas added to the container. So this is another example or emphasis, no, of the second sample problem natin. If ano yung gagawin on the last step if ganito yung questions. So, of course, ang ating formula, no, V1 divided by N1, V2 divided by N2. So, same lang yung hinahanap sa previous sample problem. So, ito yung ating formula. Okay? So, distribute lang natin. So, we have our V2 here, no, 13.5 liters. Ang N1 naman natin, no, is 7.51 moles. Ang V1 naman natin is 6.13 liters. So, distribute lang natin. Okay? So, we get what? Ano yung sagot dito? N2 is 16.5 moles. No? Kasi makancel man ito siya. Okay? So, again, going back to the question, calculate the number of moles of gas added to the container. So, meaning, yung initial mole of gas naman natin is 7.51. So, mag-deduct tayo dito sa 16.5. And our final answer is 8.99 moles. Okay, so I hope magets nyo lang. Okay, so we are now on our sample problem number 4. A 7-liter sample at 300 degrees Celsius and 280 ml pressure contains 0.8 moles of the gas. Then, adding, so naka-emphasize dyan, 0.30 moles of gas at the same pressure and temperature are added. What will be the final total volume of the gas? So, emphasize ko yung may adding later. So, ito yung ating formula. And since we're looking for V2, so again, ano man yung kasama niya sa baba, ililipat lang natin sa numerator sa kabilang side. So, meaning si V1 meron na siyang katabing N2. Okay? Ganun lang pag ano sa ating formula. So, ngayon, i-determine natin yung given. So, we have our V1, of course, the 7 liters. Ang N2 natin ngayon, since ito yung N1, di ba natin? And take note, nasa question, then adding 0.30 moles of gas. So, meaning, itong 0.8 moles at 0.30 moles, i-add natin. And that will be our N2. Okay? And of course, ang N1 naman natin, no, is, of course, 0.8 moles. Okay? Take note of that, ha? Take note of the terms na ginagamit para maging aware kayo. Okay? And of course, distribute natin yan and we'll get 9.63 liters. Again, 7 times, i-plus muna natin. 0.3 times 0.8, no? And then multiply natin sa 7 divided by 0.8 moles. And we'll get 9.63 liters kasi makancel man ito. Again, the reason why, bakit pinagdugtong natin itong dalawa, bakit yung N2 natin is, kasi meron ng word na adding. Okay? So, again, meron tayong N1, 0.8 moles of gas, then adding 0.30 moles of gas. So, meaning, ang N2 natin, mag-add lang tayo ng 0.30 moles. Okay? So, yeah. So, ito yung naging process, no? Yung V2 natin, no? 7 liters, 0.30 liters. So, ito yung, ito yung tawag nito, magagawa nyo na mistake without analyzing, no, the word adding here. Okay? Pero if you notice, no, parang lang din naman siya, no? Parang ganun lang din naman siya, no? Kasi mag-come up din siya sa tawag nito, sa same answer. But of course, as what you notice, if ito yung susundin natin, 7 liters times 0.30 mole divided by 0.8 mole, so ang answer natin is 2.627. Okay? So, if assuming na sa liters tayo nag-add, so we can just add the 7 liters and we still get the 9.63 liters. No? Basta lang talaga natin itong adding na word, no? Let's just be careful with this word. Okay? So, that ends our Avogadro's law.